exponent x over 20 equals 10. Okay, so our equation becomes 8 exponent x equals 20 times 10. All right, now we can write 8 as 2 exponent 3. Okay, and we can express 20 as 4 times 5. We can express 10 as 2 times 5. All right, so we are going to apply the power of a power rule of indices at the left part of our equation. So if you have a exponent m multiplying the exponent c, this equals a exponent m multiplying c. All right, so our equation becomes 2 exponent 3x equals, and we can express 4 as 2 exponent 2. Okay, all right. Now what we are going to do next is we are going to group the even numbers and the primes. Okay, we are going to group the numbers. Okay, I think they are all prime numbers, so we are going to group them at one side. So we group the 2's as one side. Okay, and we group the 5 as well. All right, so our equation becomes 2 exponent 3x equals 2 exponent 2 times, now 2 is the same as 2 exponent 1. Okay, 5 is the same as 5 exponent 1. All right, now let's apply the first law of indices to the right part of our equation. Okay, so we know that a exponent m multiplying a exponent c should give us a exponent m plus c. That is, when the bases are the same and the sign in between the bases is a multiplication sign, we add the exponent. So we are going to have 2 exponent 3x equals 2 exponent 2 plus 1. Okay, and then have 1 plus 1 here. All right. So our equation becomes 2 exponent 3x equals 2 exponent 3 times 5 exponent 2. All right, so at this point, we are going to divide, okay? We are going to divide here by 2 exponent 3 and here by 2 exponent 3 because we want to apply the quotient rule. So anything over itself is 1. So this part will give us 1, okay? So our equation becomes 2 exponent 3x over 2 exponent 3 equals 5, okay? Equals 5 squared. Now let's apply the quotient rule. Now let's state the rule before we apply it. So if you have a exponent m divided by a exponent c, this gives us a exponent m minus c. Okay, so we are going to have 2 exponent 3x minus 3 equals 5. Now at this point, the base here and the base here are not equal. Because of that, we are going to apply logarithms. So we say log 2 exponent 3x minus 3 equals log 5. Okay, and let's check if it's 5. It's 5 squared. 5 squared. All right, now we are going to apply the logarithm definition. Okay, so if you have log a to the power n base b, this gives us n log a base b. So our equation becomes 3x minus 3 log 2 equals 2 log 5. All right, so this is what you're going to have. So our equation becomes 3x minus 3 log 2 equals 2 log 5. Now at this point, we are going to divide this part by log 2, this part by log 2. Now anything over itself is 1, so this part will give us 1, okay? Because log 2 can cancel log 2, or log 2 over log 2 is 1. So our equation becomes 3x minus 3 equals 2 log 5, okay, over log 2. All right, now here we are going to introduce the change of base formula. So if we have log a over log b, this should give us log a base b. So our equation is going to be 3x minus 3 equals 2 log 5 base 2. Okay, so this is what we have. Now we want to make s the subject of the equation. So let's transpose all components attached to x. So the first thing you do is to transpose minus 3. Okay, so you have 2 log 5 with 2 plus 3. So it becomes positive here. And the next thing we do is to make x the subject of the equation. Okay, so in order to do that, we divide here by 3 and here by 3. So this cancels this. Okay, so our equation becomes x equals 2 log 5 with 2 plus 3 all over 3. Kindly subscribe and share.